are quadratic functions. So again, there's a definition here in 4.2. It says a quadratic function is a function that can be written in the form y equals ax squared plus bx plus c. The graph is a parabola. So what I'd like you to do is draw up here. Our parabola can open up or can open down. So in number 5, Chris, which ones did you circle? Which ones were quadratic? Call it 1, 2, 3, 4.
2 and 4.
Good job, okay, because they're U shapes. Okay, those are U shapes. So let's look at the next slide. It says in the quadratic function, f of x equals ax squared plus bx plus c, the b value affects the position of the axis of symmetry. The axis of symmetry is x equals negative b over 2a. Oops, check your blue papers. Did we put a negative there? I think I may have forgotten.
Yeah.
We did? Okay, cool. All right, so the axis of symmetry is always written as an equation in the form x equals. The x-coordinate of the vertex is the same. And here's the beauty. This is the cool connection. If I go back to what you did last night for homework, you remember we found the vertex and it was x equals the x value of the vertex. The x-coordinate of the y-intercept is going to be 0, comma, if I plug in 0 for x in the f of x, do you notice it makes the first one disappear and the second one disappear, and then it's just c? But, let's put a note here, okay? Put a note. In vertex form, if I let x equal 0, y is not k. This is the most common mistake I see. So what I try to discourage students is just plug in x as 0 and figure it out, because the most common mistake I see is students say x is 0, oh, the y-intercept's the thing at the end. And they're remembering something, but they're only remembering part of it. In standard form, it is the last number, but in vertex form, it's not the last number. You have to go figure it out. So do you see this? Let's come back up. I'm so glad I wrote this on the chalkboard. Look, when I did the y-intercept and I let x be 0, the y-intercept isn't -1. Like, here's a counter example. It was 7. So just be careful with that. All right, so let's just get to what we want to do here. So go ahead and flip it to example 1. And it says we want to graph f of x equals x squared minus 6x plus 4. So what I want you to write down beside the blank for vertex, and I want us to write it out every time until we get it memorized. Okay, I want you to write it out every time until you get it memorized. So we're going to write x equals negative b over 2a. Now the a is -1 on this one. Or not -1, that's my equal sign. Sorry, I can't see it from the board. So a is 1, b is -6, and c is 4. Do you see where I'm getting the ABC from? So now let's plug it in. So it's a -6 over 2 times 1. So that's 6 over 2, which is 3. Now that's only the x-coordinate. So the x-coordinate is 3. How do you find the y-coordinate? If we know x is 3. Plug it in, okay? Go ahead and let's plug it in. So this will be y equals 3 squared minus 6 times 3 plus 4. So I'm going to pause and give you a head start. Use your calculator, use my calculator. What do you get? -5. Okay, I got -5. So my vertex is 3, -5. The axis of symmetry is always x equals the x value. So it's x equals 3. Don't just write 3. It's got to be a vertical line, so it's x equals 3. Does this open up or down? And how do you know?
It opens up.
How do you know, Alex?
Because the a value is positive.
Okay, if A is positive, it's going to open up. And A is in front of x squared. It's in the same spot, vertex form or standard form. It's in front of where your x is. If it opens up, do I have a maximum or a minimum? A minimum. To do the y-intercept, let's write this down in our notes. You let x be 0. Okay, and this is true for lines, it was true for absolute value, and it's true for quadratics. If you want to find a y-intercept, x is 0. So I get y equals 0 squared minus 6 times 0 plus 4. Well, that's 0 minus 0 plus 4, so it's 0, 4. Oh, now watch this, okay? This is going to be very, very similar to what we did the method yesterday. Let's plot the vertex. 3 to the right, 1, 2, 3, 4, 5, down 5. That's my vertex. 1, 2, 3, 4. I'm going to make my axis of symmetry go through the vertex. Okay, make a dashed line. And then I'm going to use symmetry to get another point. Like I've got half of my U, but I don't have the other half. So if I am how many units? I'm 3 units from the y-axis. Okay, I'm 3 units and up at 4. So I'm going to go 3 units to the right. What's the name of that point? Yeah, what is it? Like, it is, Josh, but like what, can you give me the coordinates?
6, 4.
Yeah, 6, 4. So you're absolutely right. That is my symmetrical point. And so when you see the blank for symmetrical point, I want you to put it down for me. The domain is -infinity to infinity. The range. All right, so Mia, is the range the x values or the y values? The y values, nice. So Safe, what is the lowest y value on this graph? And you can look at the vertex to help you.
-5.
Good job. All right, so the lowest is -5, and it goes up forever. So it's bracket -5, 8. So let's compare and contrast to what we did Monday and Tuesday. All right, let's just pause a moment, because we're just going to do example 1 and 2 today. And pause. Tomorrow we'll finish it. And then Friday we're going to look at both vertex and standard mixed together and make sure we can do it. So the axis of symmetry is found the same way. It's x equals the x value of the vertex. Opening up and down, minimum, y-intercept, symmetrical point, domain, and range are all the same. The only thing that is different today is how you find the vertex. Let me say that one more time. The only thing that's different today is how you find the vertex. In standard form, it's x equals -b over 2a. Vertex form, we can read it off. So there's pros and cons. Okay, there's pros and cons to this. It's easier in standard form to get the y-intercept, but it's harder to find the vertex. In vertex form, it's easier to get the vertex and harder to do the y-intercept. So it's like, pick your poison, really. Which way are you going to go? So let's go ahead and look at example 2 now. The first thing is you want to find the vertex. So please, 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 let's write it one more time. X equals negative b over 2a. Okay, let's start there. So go do it. Identify b and a and go figure out the x value. Alright, so I'm going to start this one. I would do negative 8 over 2 times negative 2. So that's negative 8 over negative 4. That's positive 2. So before you get going too far, let's make sure that you have an x value of 2. Then go plug it in, and I get negative 2 times 2 squared plus 8 times 2 plus 10. Then you're going to go find the y value. So please excuse my dear Aunt Sally, that's 4 times the negative 2 is negative 8 plus 16 plus 10. So 8 plus 10, isn't that 18? So this is 2 comma 18. So my axis of symmetry is x equals 2. So David, does this one open up or down? It's going to open down, and if it helps, make a little U that opens down. Theron, would this have a maximum or a minimum if it opens down? Maximum. It has a maximum. To do the y-intercept, you let x equal 0. The reason why is on the y-axis, you're not right or left anywhere. X is 0. Yeah?
Why does it open down if it's positive?
It's negative.
The a value is negative. It's not because my x value that I got. That's just giving me the coordinate of the vertex. X equals negative b over 2a is the x coordinate of the vertex. When we're doing up and down, you're looking at the a value. That's what's in front of x squared. Good question. So here we go. I get y equals negative 2 times 0 squared plus 8 times 0 plus 10. So that's going to be 0, comma 10. All right, now one of the most common things I hear from students is, hey, 18 doesn't fit on the grid. Okay, they'll say 18 doesn't fit on the grid. Well, it can if you don't go by ones. So there is no rule book that says the tick marks are 1. And I'm not sure why students think that it has to be 1. So I'm going to go by 2s. So I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18. So we're going to go by 2s. You do not have to go by 2s on the x-axis. But it's really important that you give me some numbers for scale so that I know what you're using. Again, your scale does not have to go by ones. So that's why you don't want to start plotting until you're ready to go, okay? So you make sure you have your y-intercept and the vertex before you ever start your ticks. Because sometimes one of them will be really large and you'll need to adjust it. Something else, I know that I gave you a grid in the middle. You don't always have to have the y-axis in the middle of a grid. You can move it. All right, so here we go. I'm going to go 2, 18. That is my vertex. So I'm going to go ahead and make my axis of symmetry, because that axis of symmetry is going to help me get the other point. Then I have 0, 10. So that's 2 units away. So I'm going to go 2 units on the other side. So my symmetrical point is 4, 10. We said it's going to open down. So I mentioned this when we did 4.1. When you're done, stop and look at your work and look at the graph. This should open down. It opens down. All right, the domain is negative infinity to infinity. And who would like to try the range? Hannah, what do you think?
Is it infinity and then negative 18? Or positive 18? Or is it 18 and then negative 18?
Okay, so you're saying the right things, but not in the right order. When we're writing the interval notation, the smaller value goes first. So it is shooting down to negative infinity, but we're going to put that one first, and then it hits positive 18.